Welcome to lesson 12.4. Today we're going to look at a great shortcut called a derivative. I'm super excited to teach it to you, but before we do that, let's review what we learned on lesson 12.3, specifically with limits of values as they approach either a point, like they're instantaneous. The velocity or rate of change is what we heard a lot about last class. And so we came up with this formula saying, hey, we can find the limit or the tangent line, the slope of the tangent line, by using a limit. And so they call this y here. I'm going to change this to an f of x just momentarily. By using the formula that the limit as h approaches 0 of f of x minus h, or plus h rather, minus f of x divided by h, that this limit could give us the slope of the tangent line at any one point. And so what we learned to do last class is we would substitute in our values here. And so and this would be the slope. Let me say m equals. And so here I would have the limit as h approaches 0. I'm going to plug in x plus h everywhere I see the x in this equation. I'm going to substitute. Whoops, my bad there. That would be 10 times x plus h minus 3 times x plus h quantity squared. And then I subtract here. And inside these brackets, I'll put 10x minus 3x squared. I'll close those brackets. The reason I did that is to help me remember to distribute this negative through. And so what will happen is very frequently we will see that the limits will quickly begin to simplify. And so when I distribute here and here, I'm going to have 10x plus 10h minus, here I need to do a FOIL. So I'll do it up here, x plus h plus x plus h. We saw this a few times, last class. And technically I would need to multiply this by 3, which you can do at the start or at the end, but since we did this FOIL so many times last class, we saw that would be x squared plus xh and another hx. So we'd have 2 hx's plus h squared. I'm going to rewrite it that way. So I'll say this is 3 times the x squared plus 2 hx's plus h squared, which would simplify when I distribute that through to be 3. Oops. Let me take away the parentheses. So I'm multiplying it through. Well, there I did it again. 3x squared plus 3 times 2 is 6 hx. And then 3 times h squared is 3h squared. So I'm going to substitute that in. Right here, I'm subtracting all of that. So I'll subtract 3x squared plus 6hx. Forgot the h there. hx plus 3h squared. Finally, I'm going to distribute this portion through. I'll have a minus 10x plus a 3x squared. And all of this would be divided by h. And so I go to simplify. I see I have a positive 10x here and a negative 10x. Those simplify with one another. It looks like, let's see here, a minus 3x squared and a positive 3x squared here. So I'll rewrite this. And while I rewrite it, I will factor out everything that has, I think everything has shared h value. So I'll factor out the h and I'll say, what does that leave me with? Well, it leaves me with 10 here. I need to distribute, so it'll be a negative 6h. So the negative goes here and there. So negative 6hx, when I factor out that, will become just a negative 6x. And then here, when I factor out, it'll be a negative 3h. Only one h left over. The second h comes out over here, all divided by h. This stage, I can see that these h's simplify, and I could do a direct substitution. And so now this limit, or the slope, would equal 10 minus 6x minus 3 times 0. 3 times 0 disappears. And so we have 10 minus 6x. Now that's the slope at any point, but we specifically want the point when x is 2. That's an x. And so what's the slope when x equals 2? Is we'd have 10 minus 6 times 2. That's 10 minus 12 is equal to negative 2. And so we get A here as a solution. Now, after doing all of this problem, let's check it out in the calculator. F of x equals 10x minus 3x squared, 10x minus 3x squared. There's the graph. And on this problem in particular, we want to know the point 2, 8. And so I'm going to use that as h is 2, k as 8. And we're saying the slope of the line at any point would be 10 equals, or excuse me, m equals 10 minus 6, and it would be any x value we're looking for. I'm going to use h here momentarily, and if I wanted to graph this, I could say y minus that k value would equal, and usually we put this in parentheses. I'm using point slope here as we learned last class, would equal m times x minus h. Okay, and so as you can see here, when the slope is at the point 2, 8, we have a slope. Here's that point. I don't know why they're not showing me a dot, because they are perfectly touching one another right there at that point. You can see that the slope is negative 2 going through that point. But if we wanted to find other places on this graph, what we did last time is we just adjusted some of the points. If I said, okay, I want to know about it 0, 0, put 0, 0 here, and 0, 0 at the origin, you would see that the slope of this tangent line happens to be 10, and it would go right through that point. And you could adjust all the way around these points to find your values. So it's, as long as whatever you use for h, and the easier way even doing this would be, say, k equals f of h, just like this. Now, and I'm going to change one thing on this. I'm going to make h count by ones here. Do negative 5 and 5. Maybe that'll help me. Well, for some reason it's not really letting me. There it goes. Get a slider back. And what you can see here is, as I go through this graph, what's going to happen, let me zoom out, is every time I change h value, you can see that it's creating a tangent line going through the parabola there, and it's showing you your slope here. There's the slope when the tangent line, which is a line that just touches that graph at one point. All right, with all that extra being done, let's look at number 2 here. It says find the equation for the slope of the graph y equals x cubed plus 3x at any point. So again, the way we did this is I treated that as f of x, so I could use the same formula. And so the slope m will equal the limit as h approaches 0 of f of x plus h minus f of x. And, you know, one thing we could have done last time is probably plugged in the 2 from the get-go. You know, might have simplified our problem, but it is what it is. And so let's continue on solving this one. All right, so the limit here as h approaches 0 of f of x plus h means we're going to have x plus h quantity cubed plus 3 times x plus h minus, and it'll be minus this whole equation. You need to set those in those brackets to make sure we distribute. And so it'll be minus x cubed plus 3x. All this will be divided by h. So I need to simplify that parenthesis there. It'll be x plus h cubed, which is x plus h times x plus h times another x plus h. And so when I multiply these out, I will first FOIL the front end. We've done that on the previous problem. We had x squared plus 2hx plus h squared. And I now need to multiply that times x plus h for the third time. So I will multiply that through here, do a little another FOIL or another distribution. So x times x is x cubed. That's this one right there. And then x squared I think it said x times x. X squared times x is x cubed, and then x squared times h is h. X squared. Here I'll have 2hx squared, and then 2h squared x, and then here another h squared x, and then finally h cubed. And so when I simplify that, I would have x cubed plus 3, I'm sorry, not 1, 3 hx squareds, and then I have 3 h squared x's right there and there, and then 1 h cubed. All right, with all that, let's go write that in. So we simplified the front end here, and I have x cubed plus 3hx squared plus 3h squared x. You having fun yet? Plus h cubed. And then I will distribute this here. 3x plus 3h, 3x plus 3h. And I will distribute the negative. Minus x cubed minus 3x. Let's see what simplifies here. I can see that I have a 3x, positive 3x, and a negative 3x. Let's simplify. I have an x cubed and a negative x cubed. Those simplify. And, oh wait, I forgot to put all this over h. Okay, and now I see that each term left over shares an h, so I could do a GCF here. And we're about to have our solution. So when I factor out this h, it's left with 3x squared plus 3hx plus h squared. Oh, and plus 3. I missed that. Plus 3. There we go. And so when I go to simplify, what's going to happen is this h and this h will simplify with one another. I forgot the 0 there. And so the limit as h approaches 0, finally we're going to get somewhere. I didn't close that parenthesis there. Is we will have, I can use direct substitution. I don't even have to write the limit. Now that I can directly substitute, I can say this will be 3x squared plus 3 times 0 times x plus 0 squared plus 3. And as we know from our math, multiplying by 0 is 0, so those disappear. And it seems to me the slope would be 3x squared plus 3. 3x squared plus 3, which is answer choice C. We can check this out graphically again. And so this time I'm going to just say f of x equals x cubed plus 3x. And again, I'm going to use the same location, but this time, or same type of equation, except this time I'm going to say for m that it's 3x squared plus 3, 3x squared plus 3. And here I'm going to take off, now that I know m, I don't want to actually be looking at m for any one value. What I could do is define the derivative at any one point, or the limit, I'm sorry, at any one point. So right now I'm finding it at 2. If you plug in 2, the y value is 14, as you can see here. The derivative that would just touch that point, just perfectly touch that point right there, would actually come from this equation, which I know that looks like a line, but it's actually, when you multiply that through, it's going to be a cubic graph itself. But that would be the slope, or the equation of the slope of the graph would be 3x squared plus 3. And you can see that that is a tangent line there. And if I moved h around, let's go to like 0. Moved h to 0, you'll see there's also a tangent there. It's only touching that graph in one place and only one place. Nowhere else along the graph is it touching. So no matter what value you put in here, you would have a graph that's only touching that one spot and not going through multiple times. Now that was a hard way of doing it. Let's learn about some shortcuts, what's called a derivative.